The method of U substitution. This method deals with composite functions, where the integrand is a result of the chain rule. So we have to undo the chain rule. Like with derivatives, we have to identify the stuff, and we're going to identify the stuff as U. So we're going to say U equals stuff. In this case, it's clear that the stuff is 5x plus 7, stuff to the power of 1/2. The next thing we want to do is say what du is. So du is going to be 5 dx, or you might say du dx equals 5. Finally, I want to solve for dx. So dx is going to be du divided by 5. This box identifies our transformation, and I'm going to show a step that I ordinarily do not show when providing my work, but I'll write it in a different color to distinguish it as something I don't normally show. But I'm going to give it to you piece by piece here. Now, instead of writing the square root of 5x plus 7, we're now going to say the square root of u. So I'll write that u to the 1/2. And then instead of writing dx, I'll write the substitution for dx as du over 5. Now back to the white color. This is what I would normally show. I would say du over 5, but in every case I'm going to pull out a constant. In this case, the constant that I pull out is 1/5. So this is 1/5 times the integral of u to the 1/2 du. I normally go from this right to this. Now I have transformed my integral from x to u. I have a u to the 1/2 du, and I'm ready to use good old-fashioned antiderivative techniques. So I have 1/5 u to the power of 3/2, and then I want to divide by 3/2, but instead of dividing by 3/2, I'll multiply the reciprocal, so times 2/3 plus c, which results in 2/15 u to the 3/2 plus c. Now I will finish the problem by putting it back in terms of x. So it's 2/15 u, which is really 5x plus 7, to the 3/2 power plus c. Now remember, if I ever want to check to see if this is the correct antiderivative, I'll just simply take the derivative of this final result to make sure that I get the integrand. Now let's take a look at example 2, the integral of cosine of 4x dx. Can you tell me, can you say in your mind what stuff is, what u is? If you are saying u equals 4x, you are correct. The first couple examples are supposed to be kind of brainless. The choice of u is supposed to just jump right out at you. So anyway, du is our next step, and du is 4 dx, and then finally dx equals du over 4. Okay, there's my transformation description, and I'm going to come back over to my integral. Now this time, instead of writing the blue part, I'm going to skip over it and automatically pull out a constant. So can you see what constant gets pulled out? Can you see that a 1/4 gets pulled out times the integral? Now this is going to be of cosine of u du. So we have successfully transformed from x to u. So I'm now ready to use good old-fashioned antiderivative, or book of memories in this case, and the antiderivative of cosine u is sine u plus c. And we transform this back to x, 1/4 the sine of 4x plus c. Example 3, perhaps you want to press pause now, work it out, and then check to see that you are doing it correctly. I'm going to let u, my stuff, be 2x cubed plus 1. My du is 6x squared dx, and finally my dx is equal to du over 6x squared. I'll put a box around my transformation definition, and I'm ready to work this out. In this particular case, I'm going to show the blue step again. This is the first example so far that gives us a sense of the strategy. Before it was just do. Now we're going to talk about strategy. So let's see here. I have quantity to the power of 7, so I have u to the power of 7. Now I'm going to write this as x squared because it's still here. Then my dx is going to be du over 6x squared. This gives you some insight to why a choice of u would be important. And this choice of u is important because in my dx calculation, I get an x squared, which will cancel out with the x squared. So my goal in a u substitution is to purge myself of all x's so that everything is in terms of u and u alone. Back to what I normally write, I would look at this and see that the x squares cancel out, and I would pull out my constant of 1/6 u to the 7th du, and then I would finish the problem. 1/6 u to the 8th divided by 8 plus c, my final step being my plugging back x like this. Quantity 2x cubed plus 1 to the power of 8 plus c. So you can certainly write it like that, and some people like to write it like this. They like to write it all over 48 plus c. That's a matter of personal preference. I prefer this one here. Please try number 4. Press pause now, and then unpause to reveal the solution. I have my transformation described in the yellow box. I have to pull out a constant. I hope you see the constant that I will pull out is a negative 1/12 times, see my x here will cancel out because of the x in the denominator here, and I'm left with simply u to the 1/2 du. It is okay to put that blue step, but I prefer to skip right to this. Employ my reverse power rule. I'm going to simplify. Let's see, this is going to be negative 1 over 18. 7 minus 6x squared is my u to the power of 3/2 plus c. Example number 5. Just in case you can't read that, the denominator says x to the power of 3 minus 3x plus 1, and then that entire quantity is to the power of 6. Press pause now, work it out. My u is x cubed minus 3x plus 1, that's my stuff. My derivative, my du, is 3x squared minus 3 times dx. Now, can you think how we're going to write dx so that it's meaningful and stuff cancels out? Let's write it as du over, now I'm going to factor out a 3 and have an x squared minus 1. Hooray, that x squared minus 1 is pretty vital because the x squared minus 1 in the denominator is going to cancel out with the x squared minus 1 in the numerator, allowing me to completely purge x from the integration. I'm going to pull out a number. That number is 1/3 times the integral. So this is going to be 1 over u to the power of 6 du. Good old-fashioned reverse power rule. So let's first write this as u to the negative 6th du. And we have 1/3 u to the negative 5th over negative 5 plus c. I'll write as negative 1 over 15 quantity x cubed minus 3x plus 1 to the power of negative 5 plus c. That's the preferred method in my book, but it's just a matter of personal preference. Some people would like to write it as -1 over 15 times x cubed minus 3x plus 1 to the positive 5 plus c. Example 6 is the first example that we have some choices for u. If you are just kind of following what is stuff, you might be tempted to say let u equal 5x. Now I'd like to run through this one to show you why it does not work. So u equals 5x, suppose, and we say du is 5 dx, and then dx equals du over 5. I'd come over here, I'd pull out a 1/5 times the integral. I'd have cosine cubed of u times the sine of u du. So I successfully got rid of all the x's, but the problem is I haven't got any closer to evaluating this integral. So that won't work. That won't work. Let's try something else that won't work. Let's try u equals the sine of 5x. Again, this one won't work either, but I'd like you to see it. So du would be 5 times the cosine of 5x dx, and then dx is du over 5 cosine 5x. So I can pull out a 1/5 again. Then I have, well, look at this, I have the cosine cubed of 5x. Then I have the u for the sine of 5x, and then dx would be du over cosine of 5x. Now do you see how I am not able to successfully get rid of or purge of all x's? See, this cosine here would get rid of one of these, but then I'm still left with cosine squared of 5x together with the u. So I can't mix the u and the x and hopes to integrate. So that is another unsuccessful choice of u. So what is the correct choice of u? Press pause, work it out, and hopefully you nail it. Let u equal the cosine of 5x. This one's going to work. Du is -5 sine of 5x dx, and our dx is du over. I'll put a box around my successful transformation, and come over here. I'll use the white. I'm going to pull out a -1/5 times the integral, and this is going to be u is cosine of 5x, so this is going to be u cubed. I'll see that, oh nice, the sine of 5x cancels out with the sine of 5x, and there it is, -1/5 times the integral of u to the power of 3 du. I had successfully purged myself of x, and I'm ready to do the reverse power rule. And we can write the answer in any one of these two ways here. I would like to take a moment and answer a question that some students ask, like what about the distribution? So let's redo this a little differently and say it's -1/5 times u to the 4th over 4 plus c. And I write it like that. Then I distribute the -1/5, and then technically I would have a -1/5 c. And the reason I don't write it like that is because -1/5 c itself is just another constant. That's why these constants just get tagged along at the end.